Hello my dear grade 8 students. Now in the earlier chapters we have discussed several things related to the electricity lesson. Now in this lesson part we will be discussing mainly about the heating effect, several kinds of effects given out by the electric current. Now if you take electric current, now in the earlier cases we have studied how to connect a certain instrument to a circuit. What are the connection types? If you take electrical equipments, what are the connection types that we can observe? Then after that, we studied several things related to, or several measurements related to electric current. And we studied about the current controlling components like switches and resistors and LDRs and so on, right? So in this part, especially we are discussing about when you provide electricity to a certain equipment or to a certain medium, what are the effects that can be generated within the medium or within the material, right? So the first and foremost effect given out by the electric current is the heating effect, my dear children. So there are several effects like magnetic effect, lighting effect, chemical effect. So we'll be discussing all the parts related to effects given out by the electric current. So now let's study about the heating effect given out by the electric current. So my dear children, you know that if you take a light bulb, especially a filament bulb, I told you that filament bulbs are going to emit large amount of heat energy. Now in the earlier chapter we discussed that if you take a certain type of a filament bulb is generating heat energy as the primary medium of energy, right? That's the primary energy conversion that's going to occur within a filament bulb. Then light is getting emitted as a secondary, right? It's a secondary energy conversion. The main energy conversion is the heat energy. As the filament of the bulb is getting extremely heated, right? Due to that heat energy, like in our sun, it's going to emit light also. So that's how a filament bulb is going to work. That's why if you take the surface, the glassy surface of the filament bulbs, those glassy surfaces are going to heat up very quickly. Now if a filament bulb is being operated for about 20 to 30 minutes, you can feel that it's very hot. It's because of the heat energy generated within the filament bulb, right? So most of the energy given out to the filament bulb is getting converted to not light energy but to heat energy. Light is given out as a secondary option or else a secondary energy conversion. So let's now see what are the special and key things related to this heating effect of the electric current. How it is getting heated? What's the reason behind this heating process? And how we can utilize this heating process in making certain types of electrical appliances that we work in our day-to-day life. So my dear children, first of all, you are given with the point C. When an electric current is flowing through a wire, electric energy is transformed to heat. Now if you take any kind of a conductor, it can be a wire, it can be a metal plate, it can be an electrical instrument, whatever, right? So if you take these instruments, if you take these conductors, when you take these conductors, children, most of the times when electricity is flowing for a longer time period, each and every conductor is getting heated, mainly because of the resistance. So we'll be discussing how it is getting heated in our next parts. But up to now, I'm going to give you just a simple explanation. Because of the resistance given out by the conductor, because of the obstacle provided against the flow of electricity, most of the conductors are getting heated. That's the basic thing, right? That's the root. That's the main root or the main cause for the heating effect. So here it is given Therefore, the conducting wires get heated. So you know that part of electrical energy is getting converted to heat energy. That's why it is getting heated. Conductors are getting heated. This is called the heating effect of electric current. Now this is referred as the heating effect. When electricity is being provided to a certain type of a conductor, in any kind of a conductor, if you provide electrical energy, the conductor is getting heated, right? It's because part of the electrical energy given to the conductor, or when electrical energy is flowing through the conductor, part of that electrical energy is getting converted to heat energy. So this effect is referred as the heating effect of electricity. So it's really simple, my dear children, right? When you provide electricity to a conductor, part is getting converted to heat, mainly because of the resistance given out by the conductor. So therefore, the instrument or the conductor is getting heated. So this effect is referred as the heating effect of electric current. So it's given that we are going to investigate, right? We are going to investigate the heating effect of electric current, right? We are going to investigate the heating effect of electric current right now. So what you have to do in this process is, it is just a really simple, right, activity. So like in the earlier case, I told you that filament bulbs are generating light energy, right? You know that filament bulbs are going to emit light energy, but however, I told you that the main energy conversion which is going to occur within a filament bulb is the heat energy. It's because that the filament contained within the bulb is getting heated. It's getting extremely heated so that it can emit light energy, right? That's how the lighting effect is going to work. Now, in order to observe this condition, we'll be using a filament bulb and we'll be providing electricity to it, and we'll be observing whether it is getting heated or not. So, okay, my dear children, now let's continue, right? Now let's see how to do this activity, right? And how to investigate this heating effect given out by the filament bulbs. So, in order to do that, you'll be definitely needing a filament bulb. So, the materials that you need is filament bulb. Filament bulb. Then you'll be needing dry cells. We need dry cells, right? We'll be needing dry cells in order to provide electricity, right? Filament bulb, then dry cells. So here, right, filament bulb, dry cells. Then after that, we'll be needing a switch. Switch is actually not that much important, but however, in order to cut the electricity, it's okay to use a switch, right? Now by using a switch, we can disconnect the electric supply now. Then wires, conducting wires. So these are the materials that we need. So this experiment is really simple. What you have to do, you just need to connect these materials according to the, right now, so that the bulb would light up. It's really simple. So what you have to do, through the switch, connect the two terminals of the filament bulb to these dry cells. Then leave it for some time. Then touch and see what's going to happen over there, right? If this heating effect is getting, if the heat is getting emitted from the light bulb, definitely you can feel a warmth in the surface, warmth in the glassy surface of the filament bulb. So it's really simple, my dear children. So let's see how to conduct or how to do this activity, right? So it's given under the method in here. It's really simple. What you have to do, connect the bulb to electric cells and the switch as shown in the figure, right? Touch the glass cover of the bulb. Close the switch and let the electric current flow for few seconds. Touch the glass cover of the bulb again. Now it's given that as it is dangerous to touch an electric bulb or a part of a circuit refrain from touching electric circuit without the teacher's instructions. Now, I told you that mainly electrical energy is getting converted to heat energy in filament bulbs. So I told you once again, filament bulbs are going to extremely heat up. That's why it is emitting light energy. It's getting extremely heated up. That's why it is providing some amount of light energy also due to that extreme heat given out by the electric current. So it's not wise to touch these things, especially the things which are getting heated quite fast, right? So when you are touching these things, definitely you should get the assistance of your teacher or else an elder, right? And I recommend to you guys that if you are touching this, don't touch it with your bare hands. Just use a covering like a gloves or something like that. By that way also you can feel the warmth. Or else you can do this kind of a precaution, you can reduce the number of cells. Now in here there are 2 cells now. You can reduce that number up to 1, or else you can use some older dry cells so that it would not give that much of electric current. So according to the amount of electric current provided to the bulb, the amount of heat energy generated is also going to change. So thereby it's wise to use either less number of electric cells or else somewhat drained cells, right? By that way we can heat the bulb up to a certain level so that we can touch it without any trouble. Okay, now if you are going to provide a large amount of electricity, definitely it would heat, and if you touch it with bare hands, definitely you might get bruises or definitely your hand will get burned. So however, when you are doing this activity, it's important to get your assistant. It's important to get assistance from your teacher or else from your elders. Okay, right? Don't do it at your home, right? Don't do this thing at your home by your own, my dear children, right? Okay, now this is the method of doing the activity. First of all, we'll be connecting the instrument, or we will be connecting these instruments according to the given figure. Then after that, first of all, we are going to touch and see whether the bulb is heated or not. In order to get a certain observation, first of all, we have to check the initial condition of the setup. So first of all, we are checking whether the bulb has got heated or not. We don't know whether it is already heated, no. So therefore, we have to first touch and see whether it is heated or not, right? So we are confirming that there is no heat in the initial stage before the flow of electricity. Then after, we are going to turn on the switch. We have to close the circuit, then let it for some time. Then we are going to check whether the light bulb has heat or not, right? So that's how we are going to conduct the activity, right then. So my dear children, this is the way of doing our activity, right? So first of all, what you have to do, as per the given figure, we are going to make the circuit. Then we have to touch the glass cover first. Then after that, we have to close the switch. Then after that, we have to touch the glass cover once again. Remember, in sometimes it could be dangerous, so you have to get the assistance of your teacher, right? Right then, so we'll move on to our laboratory and we'll conduct this experiment, and let's see whether the bulb is getting heated or not. Okay, my dear children, now within this activity we'll be observing the heating effect of electric current. So already I told you that when I was starting the lesson, by providing electricity we can heat up a certain instrument, right? So I have a bulb with me, several dry cells and a switch. So what I'm going to do is, I'm going to turn on this bulb by connecting it with several dry cells like this. Here, positive terminal and the switch. So I'm going to lift the handle, connect it like this. First of all, now I'm going to check the initial temperature. So my dear children, when I'm going to touch this thing, I can't feel any temperature. I mean, like, it's in the room temperature. It's not hot, right? So there is no temperature. We'll assume that it is under the room temperature, 27 degrees of Celsius, right? So it's not hot at all. Right, now what I'm going to do is I'm going to turn on the switch and let's see what's going to happen after some while. So let's turn on. So let's keep it for some while. So when I'm going to touch this thing right now, I can feel some amount of a warmth, right? So I can feel the warmth in the bulb. Actually, it's getting very hot, right? So if you keep your fingers like this for a longer time, definitely it's going to be very hot. So what's the result of this experiment then? Upon providing electricity to a instrument, we can say that, okay, we can say that there is a heating effect, or the instruments are going to heat up upon providing electricity. Now, at your houses, you might have experience in changing electric bulbs. So if they are operated for a long time period, upon removing, you can feel a warmth. It's because of the heating effect given out by the electric current. So any instrument which is operated by electricity is going to heat up. So electric current has an ability to generate heat energy when electrical instruments or appliances are going to operate. So that's why I can feel a warmth when I'm going to touch the bulb. So my dear children, if you have been asked to remove a bulb at your house, don't touch it like this, okay? Definitely it will hurt you if it is being operated for several hours. Use a piece of cloth and then remove the bulb, okay? So this is how the heating effect is going to work. Not the bulbs, but if you take any kind of an instrument, even televisions, radio, any kind of an instrument which is operated from electricity, those instruments are going to heat up upon providing electricity. So this is the heating effect related to the electricity, right? So my dear children, let's head on to the classroom once again. Let's observe what are the other things contained in our lesson. Okay, my dear children, now we conducted the activity and you could observe that initially there was no heat energy within the bulb. But however, when the bulb is going to operate, right, or when the bulb is going to light up, you could observe that my hand has got heated up to a certain level, right? I told you that even when I'm going to touch it, I can feel the warmth and it's getting heated quite well, right? If I'm going to touch it for a longer time period, definitely I would get hurt, right? So my dear children, we could finally say that from that activity, when providing electricity to a filament bulb, the bulb is getting heated, right? So first of all, we need to write down our observation. So let's head on for the observation first. So we can say there was no considerable temperature. There was no considerable temperature before closing the circuit. Then in the next stage or in the next step we can write, you know that when we are right? When you are providing electricity to the bulb, after some while it's getting heated. Even we conducted the activity and you could observe that. So we can say in the second step, temperature has got increased after flowing electricity. After flowing electricity. Right? So temperature has got increased after flowing electricity. So this is the second observation in the earlier stage, or when we are going to start this experiment, you could observe clearly that there was no temperature, there was no considerable temperature. I mean, the bulb was in the room temperature, normal room temperature. I couldn't feel any temperature difference when I'm going to touch it in the earlier or the initial stage. But after some time, when electricity is being provided, after some time, I could feel a good warmth in the bulb. Means that there is a considerable change in the temperature, especially the temperature has got increased. So the conclusion that we can take from this experiment is that when providing electricity, filament bulbs are providing heat energy. So therefore, electrical energy or electricity is affecting heat energy. So you can write heat is affected, right? Heat is affected when providing electricity to bulb. So heat is affected when providing electricity to bulb. This is our final conclusion, right? Means that when providing electricity, or electricity is generating heat energy when it is being provided to a certain conductor. So this is our final conclusion then. Right, so let's see what are the other contents in our lesson. Now, I told you that there are different effects. So heat effect is the first one. Now, there is another activity given in here. Within this activity, we'll be investigating, we'll be studying heating effect of electric current in different metal strings. Now, in this activity, we'll be observing specially if I'm going to change the material or the conductor which carries electricity, what will happen to the heat energy generated? So that's the part especially we are going to discuss in here, right? Is this heating effect for each and every conductor is same or not? Is it getting changed when you are changing the material or when you are changing the conductor, right? So like that way we are investigating whether this heating effect is getting changed with the material or not. So in order to do that, you will be needing these materials. So let's see what are the materials that we need. So in the first figure in here, you can observe a string that has a silvery nature. This is, my dear children, nichrome. Now in the earlier lesson, when we are discussing about the measurements related to electricity, we discussed that nichrome is a type of a material that has very high resistance. So when we are discussing several questions under the measurements related to electricity, you would observe that or we have studied that, right? In several instances where we use this electrical energy to operate machines or to operate instruments that provide heat energy to us, like the heater, geysers, hot plates. In those kinds of instruments, mainly we discuss that nichrome is used as the heating core. It's because of its higher resistance. So nichrome can be heated to a greater temperature and it's getting heated quite fast, right? Now we'll be investigating that feature in here. We are going to prove that nichrome is going to heat up quite fast, quite quickly, and it's getting heated to an extreme temperature when you are providing electricity to it, rather than when you compare it with copper. So in order to do that, we'll be needing a copper string and a nichrome string. So we'll be needing, first of all, nichrome wire. Nichrome wire or nichrome string. Then copper string. Copper string. A wooden sheet. Wooden sheet. Some iron nails. Some iron nails. Then dry cells to provide electricity. To open and close the circuit, you will be needing a switch. Connecting wires. And a hammer. Hammer is used to pin these iron nails onto the wooden sheet. Okay. Right. So these are the materials that we need. We'll be needing a nichrome string and a copper string, a wooden sheet, some iron nails, dry cells, switch, connecting wires, and a hammer. Right. So these are the materials that we need in conducting this activity. Now let's go and see how to conduct or how to do this experiment. So let's observe the method, my dear children. So the method is given, right? You can see it in the figure also. Right? You can see it in the figure also. So what you have to do, fix the three nails A, B and C on the plank, keeping about 3 centimeters gap between each other as shown in the figure. Right now, we have to keep about like 30 centimeter of a gap between the 3 iron nails in here, right? I mean, like shorter wooden sheet, then it's okay to reduce the length, but however, it's wise to keep like up to 30-20 centimeters. It's not important to keep 30 centimeters in exact, but however, it's wise to keep around 30 centimeters, right? It depends on your wooden sheet, however. Okay, but don't keep it much closer, right? Like 5 to 3 centimeters. Don't keep it like much closer. At least keep the gap between the 2 iron nails at least to about 10 centimeters. Okay, right. So the next step we'll see, tie the copper wire between A and B nails and nichrome wire between B and C nails. Both wires should be well stretched. Alright, now what you have to do, you have to connect the wires, the nichrome wire and the copper wire, like in the figure given. AB copper wire, BC nichrome wire. You know that iron is a good conductor of electricity. It's a good conductor of electricity. So through iron nails, electricity is getting conducted. So when you connect this one like this, the electricity coming through the positive terminal travels through the switch, comes to A, and it's going to travel through this copper string towards B, then through the copper wire or copper string to the B, and then it's coming towards the nichrome wire to C, and once again back to home to the dry cell, right? So this is how it's going to flow. Electrical charges is going to flow like that, right? It's coming towards the copper wire, then after that from the copper wire it's traveling through that AB terminals, then after that through BC terminals which has the nichrome wire, then back home to the dry cell once again. So this is how it's going to work. So by that way we can compare, I mean like you can touch these two wires, nichrome wire and the copper wire, at the same time by using your both hands, or else you can check it by using one hand, like when I'm going to touch the copper wire, and after that I'm going to touch the nichrome wire, then we are going to observe what's going to happen over there, right? Okay, so here tie the copper wire between A and B nails and nichrome wire between B and C nails. Both wires should be well stretched, right? Both the wires should be well stretched. Then connect the nails A and C of the plank to the switch and the dry cell with the connecting wires as shown in the figure. Now according to figure you have to connect the instruments. Touch the copper wire and nichrome wires, then close the switch for about 1 minute and allow current to flow and touch the two wires again. As it is dangerous to touch a part of a circuit, refrain from touching electric circuits without the teacher's instructions. Discuss your observations finally. So like in the earlier case, what you have to do? You leave this system for about 1 minute after providing the electricity, right? Then check which metal string is going to heat up very quickly, or which one of these two strings is going to provide huge amount of temperature after electricity is going to flow through it, right? So we have to observe quite well, right? So in that way we can compare the two temperatures of the strings. From that observation we can come into conclusion that which material is going to provide more heat energy and which material is going to provide less energy. So which materials can be utilized for heating equipments and which materials cannot be used or utilized in heating equipments, right? When you take these equipments, these should definitely use electricity. So I'm talking about these household equipments that we use heating effect. What kind of a material that we can use? Most of the times you know that we are using copper as the conductor, but however in heating equipments we can't use copper, right? In heating equipments we can't use copper, right? It's mainly because of copper having lesser resistance. If it has less resistance, the heating effect given out by the copper is going to be very less. So we are confirming that thing from this activity. Right, my dear children, now let's head on to the laboratory once again and we'll conduct this activity and let's see which of these strings are going to heat up quite fast to emit more amount of temperature. Okay, my dear children, now in order to identify the heating effect quite well, here I have prepared a special kind of a setup. Within this setup, there are 3 iron nails, 1, 2 and 3. And for the first 2 iron nails, for the first one and for the second one, I have connected a nichrome coil. So this is a nichrome coil, nichrome string. You know that nichrome has very high resistance, right? In the earlier chapter, lesson 8, right, we studied about the nichrome, that it has very high amount of resistance. And this one, which runs through the second iron nail and the third iron nail over here, is a copper string, right? Copper string. So these two are being connected here to a 9-volt dry cell which runs through a switch and which comes to the nichrome coil once again to here. So the circuit is getting completed like this. From positive terminal through the switch, through the other terminal, through the nichrome string, towards the copper coil, towards the other nail, comes back to the negative terminal. So now what I'm going to do is I'm going to turn on the switch, and by touching each of these strings, I'm going to check the temperature, right? So we have to turn it on and keep it for a while. It's because that here we are studying about the heating effect now. So in order to identify the heating effect, we have to keep it for some time. So let's wait for some while and we'll observe what has happened with the temperature. So initially there was no temperature. You could see that I was touching it, right? So let's see what happens after some time. So okay, my dear children, now let's touch and see. So it has a good temperature. Even I can't touch it with my bare arms. Nichrome coil has a very good temperature. But the copper thing is, it's still not like I can touch it my bare arms without any harm. There is no problem in touching this thing, but this thing is really hot. So it's actually really hot. If you are going to touch this thing, right, you can feel the warmth very well, right? So it's really hot. Even my fingers are getting, right, heated up, or fingers are getting burned when I'm going to touch this thing. So this is very hot, but still there is nothing in this one. But in here you can observe it's very hot. Okay. So within this activity we can see that when you compare the heating effect of copper and nichrome, right? This is nichrome, right? So it's very hot right now, but copper, it's not. So I'll turn off the, right? Still it is hot. Now I can touch up to a certain extent. And now it's been weared off. Once again, when I'm going to connect the circuit, it is getting heated up very quickly. Yes, but however, the copper, there is nothing. So by conducting this activity, we can say that, my dear children, nichrome is a type of a metal which is getting heated up very quickly. It's because of the resistance bear by the nichrome. In nichrome, there is high amount of resistance. So if there is high amount of resistance, upon flowing electric current, it's going to heat up very quickly as there is more obstacle against the current flow. So the particles are getting collided, or these electrical charges are getting collided with the surface of the nichrome coil, creating some amount of a heat energy. So that's why nichrome coil is going to heat up very quickly. But however, if you take copper, copper is not providing that kind of an obstacle or that kind of a resistance. If you are going to connect a copper wire into a circuit, that's why mainly that we are going to use copper as conducting wires, because the loss of electricity is very less. So these are my observations now. What were my observations? Nichrome coil has got heated very quickly and it is providing good amount of heat when you compared with the copper one, right? So the copper string is not getting heated. Actually there is heat but very less amount when you compared with the nichrome coil. Let's study first. In here, it's really important to study, not to write, right? Okay. So we'll study about more things related to electricity and how this heating effect is going to work with the resistance. Right. So let's head on to the classroom and we'll do our other things related to the lesson. Okay, my dear children. Now we conducted the activity and you could observe that there is a huge temperature. There was a huge temperature when I'm going to touch the nichrome wire. Even I can't touch it with my bare hands. It's getting burned. My hand is getting burned, right? So, however, if I'm going to touch the copper wire, there was no such effect. I mean, like from our bare hands, we can touch it without any trouble. It's getting heated up to a certain extent. But however, I can manage that heat. My body can bear that heat. My hand can bear that heat. When I'm going to touch the nichrome coil or the nichrome string, my hand can't bear the temperature given out by the nichrome wire or the nichrome string. Even I can't touch it with my bare hands. Very heated, right? It's been heated up to a it's heated up to a very high temperature, right? So if I'm going to keep my hand for a longer time, definitely I would get a burn, right? Definitely I'm getting a burn from the nichrome wire. That's why it's been instructed specially that when you are touching these things, especially these heating equipments, it's important to take the instructions and it's important to get the assistance of your teacher or else your elders. Right then. So my dear children, we'll be writing down our observation from the activity. So our observation was quite simple. Nichrome string is heating very fast compared with the copper wire or the copper string. So we can write like this. Nichrome wire is heated up nichrome wire is heated up very fast than copper wire. Nichrome wire is heated up very fast than copper wire. So the conclusion that we can take from this activity is that when you take copper and nichrome, these materials have different heating effects when electricity is being provided, right? So by that way we can conclude that finally different conductors are providing different types of or different kinds of heating effects when they are connected to circuits, right? So we can say that finally different materials have different heating effects when passing electricity. Right. So different materials have different heating effects when passing electricity. So when passing electricity through different materials, the heating effects is also going to differ. From material to material, we can say that the heating effect is also going to change, right? So these are our observations and our conclusions from the activity, my dear children, right? So now let's observe what are the other contents given in the heat effect or the heating effect given out by the electric current. So it's given that for the external edge thing, see, resistance of wires made of nichrome and manganese is higher than that of wires made of copper or aluminium. So the heating effect given out by nichrome and manganese, right, is very high. It's because they are having higher amount of resistance. The obstacle given against the current flow is very high in manganese and in nichrome. So when the obstacle is getting higher and higher, right, electrons or the electricity, so electrons are type of a subatomic particle contained in these particles in atoms. So we have studied about the atoms under the 4th lesson, my dear children, when we are discussing about the nature of the matter, right? So under the discontinuous nature, we have studied about the matter, right? And we studied about how matter has got created. We discussed that each and every matter is created up with smaller particles which are referred as atoms. Now within these atoms, there are special kinds of particles which are referred as electrons. Electrons. So we'll be studying about electrons in the next year in grade 9. So up to now, just remember, you know that matter is made up with particles, and within these particles there are special structures which are referred as electrons. So when passing electrons from one place to another, electricity is generated. That's how electricity is getting generated. A current means flow of electrical charges. You already know that electrical charges are electrons. In simple, electrical charges are electrons. Okay, so my dear children, electrons or these electricity is kind of a material. I mean, like, it is kind of a subatomic particle, very smaller particle, electron. When these are passing from one place to another, if the obstacle given out by the surface is very high, then what would happen? It's like this. Dragging a chair on a concrete floor, it's like dragging a chair on a concrete floor which is not smooth at all. So in that case, heavy amount of sound is given out. And the other case is that if you drag it quite fast, you could feel definitely a warmth within the chair plus with the concrete floor as well, right? Now take your hands, keep it like this and rub it against like this very well. You could observe that when I'm going to rub it down quite faster and heavier like this, my hands are getting heated up very quickly. It's because that our surfaces are not that much smooth. They are somewhat rough. So when I'm going to touch one surface with the other, due to that nature of the surface, my hands are getting heated up. So when electrons are flowing from one particular surface to another, or when these electrons are flowing from, or when these let's say electrical charges, you don't know about electrons quite well in these times, no? So let's say electrical charges. I told you about the electrons in order to give you an idea that these electrical charges are also type of a smaller, very tiny type of a material. Okay, so in order to give that certain particular idea that these electrical charges or electricity are made up with very smaller tiny particles. So when these tiny particles are passing very high or at a very high speed through a certain surface, like in the earlier case, like when we are rubbing our hands quite fast, you could feel that a heat is getting generated. So when the surface is smoother and when the surface is giving out a good push for the flow of electricity, the surface is not getting heated quite well, like in the copper and aluminium. But however, if the surface is quite hard and when it is going to be rough, I mean, like, we can't observe the roughness. But however, if I'm going to go to the micro level, it's like that. That's how the nature come into action when you are comparing the flow of electrical charges. Nature of the surface, nature of the substance is the one which is providing a good resistance. So that's why electrical charges are going by taking that heavy obstacle. So when it's going to take that heavy obstacle and going to travel past through it, the material is going to heat up quite well. Like when we are rubbing our hands quite fast and when we are rubbing our hands very slowly, right? So the nature of the surface is the main reason for the heating process. When the nature of the surface is getting changed, the obstacle given against the flow of electrical charges is also going to change. That's how the material is getting heated up. So my dear children, specialty in here is that when you take copper and aluminium, those surfaces are very smooth. I mean, like, they are providing a good support for the passing of electricity or electrical charges from one place to another. There is a small bit of a resistance, or there is a small bit of an obstacle. But however, that obstacle is not that much greater as like nichrome or else manganese. So therefore, aluminium and copper are not getting heated due to lesser resistance, and the wastage of electrical charges is also very less in copper and aluminium. That's why we are using these materials as conducting materials. As conducting wires, we use aluminium and copper. Normally in our houses, we use copper wires. When people are going to use, like, in heavy wires, I mean, like, heavy wires means larger wires with larger cross-sectional area in order to carry large amount of electricity from one place to another, and then in that case we use aluminium, right? So aluminium and copper has very less amount of resistance. Silver is also a type of a metal that has very less amount of resistance, even lesser than aluminium and copper. But however, silver cannot be used commercially. It's because silver is very expensive, right? Right, my dear children. So in the next point, it is given how does the heating effect is going to work with the materials. Heating effect of an electric current depends on the resistance and the current flowing through a conductor. So I told you that it's going to depend on the resistance. And the second factor is the current, the amount of current flowing through the conductor. If more and more electrical particles or electrical charges are going to flow through a conductor, that blockage is going to be increased. When increasing that blockage thing or the obstacle, the material is getting heated quite fast. Okay, it's obvious. So next one, when the resistance of the conductor is high, more heat is generated. So here we can say, when the resistance is high, when the obstacle is high, more heat is generated. When the current flowing through the conductor is high, more heat is generated. So when the current flowing is high, right, more heat is generated. Right? When current flow is high, more heat is generated. And the other case is that when the resistance is high, more heat is generated. Resistance of a conductor depends on the material it is made of, its length and its thickness, area of the cross section. So resistance of a conductor depends on the material it is made of. So I told you that according to the nature of the substance, according to the material which the conductor is being made of, like in copper and nichrome, I told you that the two resistance levels are going to change. So the resistance is changing because of the nature of the material. Then its length of the conductor. So I'm going to give you a simple example, my dear children. Let's take a 100-meter race and a marathon. If we assume 10 people are going to participate in a 100-meter race and a marathon, right? At the same time, now I'm going to give out a signal to start the race. You know that within like 12 seconds, right? I'm not talking about international athletes, just for an example, right? So within 12 to 15 seconds, definitely the 100-meter race would end. The specialty is that all 10 athletes are going to finish the race. What's the reason over there? Lesser length, lesser distance. So all the runners can run quite fast to the end. But what happens in the marathon? After some time, now marathon is being started, you could see that after some time, like 1 or 2 hours, actually in the race, like earlier there was 10 people, however like 1 or 2 hours there was like 9, there's like 9 or 8, 2 or 3 people are missing from the race. Why is that? Because those people have got hurt, or those people have some kind of an issues with their legs, or some might fall. What's the reason for that? It's because of the distance that they would have to cover during that marathon race. So higher the distance, the particles or the people are getting tired quickly, right? So thereby some particles are, or some people from that race are going to drop down at the, like when the race is going to start, some people are going to drop down at the middle. Like in the same way, when the distance or the length is high, some amount of electrical charges are going to left over. They would not be able to travel to the end. They will left behind at the middle. So if 100 electrical charges are coming from one end, all 100 electrical charges will travel to the other end if the distance is very less. Like in the 100-meter race, all the athletes are going to finish the race quite fast and very well. But if the distance is greater, right, if the distance is greater, like in the marathon, if 10 athletes are going to start the race, to the end, like 9 or 8 people would come. It's because of the distance. Some or few people may left behind. So the same thing would happen to the electrons as well. If the distance or the length is greater, what will happen? If I'm going to put 100 electrical charges from the starting position, and I'm going to count how many electrical charges are coming to the ending position. So definitely if I'm going to put 100 here, over there would be around 90 or something like that. Definitely it should be less than 100. So my dear children, the electrical charges is going to travel from one place to another through conductors. However, when the length is going to increase, more and more obstacle is getting provided by the surface. In that case, the resistance is going to increase for sure. My idea is that in simple, shorter conductors do not heat up very quickly. However, lengthier conductors heat up quite fast. Okay. Coils are getting heated very quickly. However, wires are not getting heat up very quickly. In a coil, there are more rounds. Rounds means more length. So it's heating very quickly. Right. So this is my simple idea. Right. So the next one is the thickness. Or it is given area of the cross section. So it's like this. These two are two conductors. You could see that if I'm going to mark this one as A and this is as B. In A, the cross section means this surface. When you're going to cut it from the middle or else from a corner, the area of that surface, outer surface, is the cross section. This one is the B one, okay? The B conductor has a higher cross sectional area, you can observe it. So if I'm going to put 100 electrons to this side and 100 electrons to this side, from which conductor does the 100 electrons are going to come very fast without any trouble, without any hesitation, right? I mean, like, really simple. You are being asked to travel from a larger door like this, and you are being asked to travel from a smaller hole like this. Which one is easy to travel, right? From the door or from that hole? Obviously from the door, because it has a good cross-sectional area. Means that we can travel quite fast. We are not going to stuck. But however, in this part, the area is less. So there might be a chance that we could get stuck in between the tunnel or whatever the thing in here. So that's how the cross-sectional area is going to work. When the cross-sectional area is greater, more and more particles can come and jump out from the system very fast. But however, when it is getting lower, less number of particles are getting out from the conductor. And the number of particles which is going to flow out from this conductor is also very high rather than this. You know that these things are particles, no? So these things are particles and they travel at the same speed. So children, from this one, the particles will travel to the other end very faster than the other, right? So this thing, the thickness, is also going to depend or also going to change the resistance factor. In these, which has less thickness, less number of electrical charges are coming out. Okay, listen to me very carefully. Less number of electrical charges are coming out. So if less number of electrical charges are coming out, my dear children, what will happen to the current flow? Current flow would be definitely decreased, not increased, it should be decreased, as less electrical charges are coming out. So if the current is less, you know that current and resistance have opposite relationship. So if the current is less, high the resistance. Once again, listen. The electrical charges coming out from the smaller one, right? This one, A, is very less. If less electrical charges are coming out, current coming through the conductor or current flowing through the conductor is also less. Less electrical charges, less current. More electrical charges, more current. So if the current is less, resistance is high. Okay, if the current is more, resistance is less. It's because that these two guys are showing, or these two factors are showing an inverse relationship. When somebody is going to increase, the other drops down. When something is going to drop down, the other is going to increase. It's like eating ice creams in a warm sunny day and eating ice creams on a cloudy rainy day. In a cloudy rainy day, right, the number of ice creams which are going to sell is going to be reduced. Definitely it would reduce. According to the amount of rain that's going to receive, definitely the ice cream selling is going to reduce. If heavy rains are going to come, definitely there won't be any sale of ice creams. Heavy rain, no ice creams. Less rain, more ice creams. In the same way, see here, more particles, less resistance. More electrical charges, less resistance. Less electrical charges, more resistance. That's how the thickness is going to work. So my dear children, thickness or the area of cross section, it's showing an opposite relationship, right? It's showing an opposite relationship with the resistance. When the thickness is higher or when the cross sectional area is higher, more and more electrical charges would come out. Then the current flow is greater. If the current flow is greater, lesser the resistance. If the thickness is lower, then less number of electrical charges are coming out. If less number of electrical charges are coming out, resistance is greater as there is less current. Right then. So these are the three main factors that depends the resistance. Material which it is made of, length of the conductor, and the thickness or the cross-sectional area. So therefore, very thin long nichrome wires are used in electrical appliances in which heat is generated using heating effect of electricity. Very thin. It should be very thin. If it is larger, then larger electrical charges are coming out, no? So it should be very thin. Okay. So very thin, long nichrome wires are used in electrical appliances in which heat is generated using heating effect of electricity. Right. Very thin, higher the resistance. Long, once again higher the resistance. Nichrome, very high resistance. So all of these three factors are coming together to create a heavy resistance. Heavier resistance means heavy amount of heat energy. So that's how these heating equipments are created that utilize electricity. Right. In our day-to-day life, there are electrical appliances that use heating effect of electricity as well as the appliances where the same effect is disadvantageous. Now, if I am going to take a filament bulb, the energy that we need from a filament bulb is not the heat energy. We need light energy, no? So, light energy is getting generated as a secondary unit or as a secondary energy conversion. So that all heat energy, like more than 50% of heat energy, more than 50% of electrical energy given to the filament bulb is getting wasted. We can't utilize that energy, that heat energy. So my dear children, in some electrical instruments, this heating effect is very disadvantageous, right? It is a disadvantage. Like in each and every electrical appliance that we used in that we use in our day-to-day life, in order to make our work easy, but which do not provide heat energy as the main energy conversion. I mean, like in a washing machine, we use the kinetic energy of the rotation, right? In a light bulb, primary energy that we need is light energy. In a radio, we need the sound energy. In a television, we need the light energy and sound energy. So in each of these cases, heat energy is not necessary at all. Why do we need to get heat energy from a washing machine? Can we like iron clothes from a washing machine? No, we can't. Absolutely we can't, right? So we need the kinetic energy, not the heat energy. So my dear children, in those cases, like in a television, radio, washing machine, fan, in these electrical appliances, the generation of heat energy is quite a disadvantage for us. Okay. So there are some certain electrical instruments that this effect is being utilized, but however for some instruments this effect is a disadvantage. Right then, so let's see what are the other contents given. So you are given with a table, list out some day-to-day appliances in which the heating effect of electricity is effectively used. Tabulate the appliances you identified according to their use. So I'm going to complete this table, my dear children. There are 5, 1, 2, 3, 4, 5. There are 5 rules given. So I'm going to complete these 5 rules. So you find out some other appliances that use or that utilize electrical energy in order to provide heat energy for us. Find out some other instances and write their purpose as well. So you can make a small booklet by writing down their specifications like the voltage, the power it's going to use, the current which is being utilized. You can find all of these details at the bottom of the instrument, right? Definitely those things will be printed or a sticker will be pasted on the instrument for sure, right? Or else if you have, you can check the outer covering, that cardboard cover. In that also you can observe these details. So you can prepare a small bit of booklet or by writing down all of these things. Right then, so let's see the name of appliance and the purpose. Let's see what are these instruments. So you know that heaters, right? Heater. We use heater to boil water. Then a hot plate. We use hot plate to cook food, right? Rice cooker. Right? Rice cooker to steam rice. To steam rice. Rice cooker. Then ovens. Ovens to bake food. Right? To bake food. So these are like 4 appliances, right, that we use in our day-to-day life. So I'll write another one, bath. We studied about the bath, right? We studied about this thing when we are discussing about that thing related to, or that activity related to soldering equipments, right? So we use bath to solder instruments or to solder equipments to a circuit. To solder circuit components. Solder circuit components, right? Then so there are like 5 instruments. Okay, so there are like 5 instruments. So these instruments are using in these cases. All of these instruments are utilizing the heat energy generated by the electric current. Right then, so let's move on with the next slide, my dear children. So here it is given, heating effect of electricity is disadvantage in some electrical appliances. Various methods are used to avoid damages that happen due to this heat generated in them. Heating effect of electricity is a disadvantage in some electrical appliances such as computers, and cooling fans are used to cool such appliances. So in computers, you know that there are fans. If you turn your computer to the other side, if you check the back side of it, definitely you can observe fans. These fans are used to minimize the heating effect, right? To cool the systems or to cool the circuits. So in computers, we use fans more often. And other than fans, these instruments which are referred as heat sinks are also used, right? It can absorb heat energy and it can expel heat energy quite fast, like the radiator in your vehicles, okay? Heat sinks. So heavy duty semiconductors such as transistors produce heat. Therefore, heat sink is used to cool the appliance. So transistors, transistors. Semiconductor means they are going to partially conduct electricity. At a certain instance, they are passing electricity. At a certain instance, they are not passing electricity, partially conducting. So these materials which partially conduct electricity, they are heating up quite fast, like the transistors in circuits. So we'll be studying about transistors in grade 11 in detail. But however, up to now, you just keep in your mind, there are some circuit components like capacitors. We studied those things in grade 7. Diodes, studied in grade 6. LEDs, resistors, variable resistors, LDR. Like that way, there are several electrical components, right? So transistor is also like that, a type of an electrical component. Specialty in transistors is that these things are semiconductors, means they are passing electricity partially. So therefore, transistors are getting heated very fast rather than the other materials. Other materials means other electrical instruments. So in order to remove that heat energy generated in transistors, we are going to use the instrument called the heat sink. Okay, it's like a radiator. Right. So my dear children, see, for extra knowledge, it's given nichrome is an alloy made by mixing nickel, chromium and iron, right? So nickel, chromium and iron, all of these three substances are getting mixed, mainly nickel and chromium, but however there is iron as well, right? So nichrome is an alloy made up by mixing nickel, chromium and iron. Alloy means it is a mixed metal, right? It's a mixed metal. So there are three metals, nickel, chromium and iron, right? So nichrome has a high amount of resistance. So my dear children, I hope that you took us good knowledge about this heating effect. Now in modern day computers, rather than using these heat sinks and fans, there are liquid cooling systems as well. In gaming computers, there are liquid cooling systems. There is a liquid, right? We are going to add that liquid to the casing of the computer and that helps for the cooling effect. So there are liquid cooling systems in nowadays for the computers, much more effective than these, right? So when the technology is getting advanced from day by day, more advanced methods are being invented to reduce this heating effect. Right, my dear children. So we studied about the heating effect of a current, and I hope that you got a sound knowledge about this lesson part. So in the next chapter, we'll discuss the other effects given out by the electric current.